join us. So, can you see my screen quickly? Type yes in the chat board if you can see my screen quickly, because I'm sharing my screen with you now. So if you can see my screen, please type yes, um, so I know quickly that you can see my screen. Good stuff. Good stuff. So now, last week we had the first class. Most of you will recognize this. So most of you will recognize this screen. So trying to show you the all of my screen, so you see everything. I think this is better. Yeah, great. So last week we started the class and we went through some fundamental of testing that you guys should know. So today we're going into chapter 2 of the ISTQB syllabus in software testing. And the stuff we're going to learn today is the core of what a test analyst does. Okay, so this is really important. You're going to come across a lot of these things that you're going to learn today, a lot, compared to things that you not necessarily hear from other people, learn from anywhere else, or that you would wait till you start practicing before you can learn. The first and second and third classes are the absolute necessity that everybody needs to know. Before you can actually practice testing. So it is really important that you understand this first and second and next lectures very well, and ask any question. If you're lost, please don't, you can stop me anytime to ask questions. So let's kick off quickly. So welcome Jalili, nice to have you here as well. So we can start quickly. So at the end of these lessons today, you should be able to answer the following questions. And these are the areas we're dealing with today: software development life cycles, models, different types, a few examples. There are so many now that has been concocted out of so many different standalone methodologies. We're going to learn the fundamental ones, the absolute necessary foundation ones. And we're going to learn about test types, and we're going to learn about test levels, and we're going to learn about maintenance testing. So at the end of the day, you should be able to answer these questions. Now, for those of you thinking at the end of all of this, I'm going to go ahead and get certified, these are the sort of questions you get in the certification exams. Some of these are like multiple choices. Some of these you have to break it down and explain. So I would pay attention to these things if I were you. Okay. And also, some of these do come up in interview for junior roles, because these are the basic things that you should know as a test analyst. So at the end of the session today, you should be able to answer these questions. And remember, if you have any question or anything, please let me know, and we can, I'll try as much to answer your questions, okay? So here we go. Software development and life models. So now, during the development of any application or system, and this includes non-software as well, infrastructures, hardware, and so there are different phases to it. There are different components, elements of a development project. So you have somebody who might be the client or the customer who wants to do something, okay? And there's somebody who can organize people who can do those things. And there are some people who can actually do the doing. I call it, they do the doing. And then there are some other people who look at it and go, yep, it's correct, it's good to go. Now, we call it the software development life cycle. SDLC issue. So don't be phased. If someone says, "Oh, what do you know about SDLC?" or "What's your understanding of SDLC?" SDLC simply means software development lifecycle. Okay. Now, SDLC um, model describes the type of activity. Okay, the, the type of activity performed at each and various stages of a software development project. And because we're focusing on software testing, we'll limit ourselves to software development, but this does not necessarily mean is only applicable to software development. Okay, it's all sort of development. So, and it describes the activities performed at each stage of it and how the activities relate from one to another, either logically or chronologically. So, in chronological sense, one has to follow the other. Like saying alphabetically, A comes before B, before C, before D, and all. You can't say A, B, C, Q, P, J, W, Z, F. No, it doesn't work like that. You're going to end up confusing yourself. It has to go from A to B to C to D, and so on and so forth. It has to go from 1 to 2 to 3 to 4, and so on and so forth. Same thing with software development. Now, if you look at this diagram that I've put on here, you would see one is planning. Okay. Now, you need to understand something. This happens in this sequence, but not necessarily happens in all projects. This doesn't necessarily happen in all projects. Some projects merge some of this together, but fundamentally, you need to understand that this is how things happen. Okay. And for some testing models, for every activity you do, there is a corresponding test activity. Every development, analytical, research, requirement analysis, and all of that activity you do as a standalone, there is a corresponding testing activity that goes with it. Okay. So for everything we do on this side as developers, there's something we do on this side as testers. So there are so many different models that's in the market. But fundamentally, I'm going to teach you about two. We're going to talk about it in full, and then we're going to talk about how they differ, why they differ, what not. Okay. Now, you need to understand that each of these stages in this life cycle has objectives. Okay. Each of them have objectives. Why are we doing this at this point in time? Okay. So you need to understand why you're doing it, what the output is, what is your end game, how do we measure this, why do we need to do this. You need to understand all of that. Okay. And for each of these, there are so many different people that are involved in it. The tester, well, the test analyst or the tester is just one person, or it could be a team. So it could be a team of testers or one tester. Okay. But either a team or one person is just one part of the team of people that will go through the life cycle. Okay. So if we run through the planning, analysis, decision making, implementation, testing and integration, maintenance, and it keep on going in cycle. So we want to develop something, we'll write our requirements down, we plan it. How long is it going to take us? Do we have the money for it? How many people do we need? And then we analyze it. How does it work? How do we build it? Who's going to do the building? Where are they? How do they build it? What language do they build it at? Which template do they use? Which environments and stuff? And then we decide, okay, we've received representation from X, Y, Z, and all of that. So we're going to use X, Y, Z. And then the actual development starts. We implement the plan. We put the plan into use. We do all of it. And then we test it. Once we've tested it, we put it into service. And after it's gone into service, it goes into maintenance. And you will see all of these things work together in a little bit. But you need to understand that software development is much more than someone sitting in a corner and writing a code. Um, I understand in the Nigerian context, you guys might not have seen a lot of testing happen. And it's probably because it happens offshore and you don't know, or because they don't do it as well. Jalili, yes, customer has to be part of the planning team. We call them stakeholders. The customer is paying you. So the customer needs to know when they'll get the product. The customer needs to know how the product will work. The customer needs to know how the product will be deployed, in which environment, on what domain. For example, you have the Unix, you have Windows. Is it a Unix product? Is it a Windows product? Where do you use it? So the customer, as a stakeholder, yes, should be part of the planning team. Okay, but usually this is outsourced to a project manager. Now the project manager becomes the customer, or the product manager becomes the customer, and feedback to a program board or a project board. These are a sort of high-level stakeholders that don't necessarily come to the shop floor every day, but they are part of the project. Okay, so we need to understand that. And in every software development lifecycle model, you need to understand a few things. But does the customer take part in any of the final check in the testing and integration? Yes, they do. We'll come to something called user acceptance testing, operational acceptance testing. We'll come to that in a little bit, show. But yes, they do. They have to use it on the other side of go live before it actually goes live, so they can tell you or sign off. We call it. They sign it off. That's like saying you've purchased this thing. This is my receipt. Okay, so the customer has to participate in it, but you would see where and how uh, as part of this session. Actually, we're going to get to that today. Quickly, in every life cycle model, you as a tester, you need to understand what good testing concepts are. Okay, for everything your developer, the planner, the researcher, the analyst do, there must be a testing counterpart of it. You can static test anything. You don't have to click a button to test anything. There's so much you can do testing that you don't have to touch anything. Static testing is good. You'll see that. I'll teach you that. Each test level has objectives. Each of them has objectives, and you should know the objectives. Okay. And you as a tester, okay, you do your own analysis. How you are going to test it. How long the testing is going to take you. How many people do you need on the testing? There's something we call test estimate. As a test manager, I call it test guesstimate because we really don't know, we're guessing. I could go to my client and say, I need 6 people for 7 months. And they could give me 6 people for 7 months. We could be happy and dory doing our stuff. 2 months into the project, something catastrophic happens. And I lose 4 months. Do I still think I can go live with the time frame and 7 testers? And nah, it's not going to happen. So I need to go back to them and ask for more resources and stuff. So it's always an estimate. So we don't know that. So you as a tester need to understand that for each level, you need your set of documentation. You need to provide your key deliverables, your documentation, the things you need to show your output. Remember, we talk about our test scripts, test cases, scenario, schedule, and all of that last week. You need, for each level, you need to produce those things. So you know that these are good testing concept that you should understand. And none of these things happen haphazardly. They happen in a structured, logical, chronological phase, leading from A to B to C to D. Okay, always remember that. It has to go from A to B to C, not haphazardly. Okay, so you need to always remember that and know that it has to go from one to another. Okay, now there are a few software development lifecycle models out there. Before the Agile came in, and get crashed, and now everyone thinks they are doing agile. First of all, let's go back to the basics. The next slide is going to show you two different modules, and I'll talk you through. And we'll talk about the concept of them, why we used what, which, how, and stuff, and then we'll continue the class, okay? You can drop your question anytime. I'll try to answer your questions as we go. Now, look at these two diagrams, okay? Now, these two diagrams on this side, I hope you can see me here. On this side here is what we call the V model. And on the right-hand side is what we call the waterfall model. Remember that these two are a key component of what you need to know as a software tester. So let's go through it. Now, let's start with the V model, right? Now, if you look at the V model diagram, on your left-hand side, you would see a set of activity happening, slanting down rightwards. And on the right-hand side, you see corresponding activities on there. And if you look at that diagram carefully, you would see that for each corresponding activity on the left-hand side, there is a corresponding activity on the right-hand side. So let's start from the beginning, coding, okay? So the reason I use this diagram is because there is a fundamental flaw there. And I will leave you guys to point it out to me, but let me keep walking you through it. So when you find it, tell me, okay? Right. So at the beginning, at the very bottom, it's got coding in it. Now, I wouldn't say that is coding, but I'll leave you to point what should be there to me in a minute, because we've literally just talked about it a few minutes ago. So low-level design. What is low-level design? That's someone writing codes. So I want to design a blender, and blender has few components. So I'm coding for one of the components. So I'm writing my code. Yeah. Now, when I finish writing my code, I test it. That testing is called unit testing. That testing is usually done by the developer. We talked about this last week. That testing that is done at the coding level is done by the developer, right? Now, this lacks a fundamental concept. Yes, it's recorded, Faisal. This lacks a fundamental concept in testing, something we call degree of freedom. Now, let me tell you briefly about degree of freedom. Degree of freedom means you do something, you hands off it, let someone else look at it. You need another pairs of eyes to look at it. So that's the degree of freedom. Usually as a tester, you want to have 100% degree of freedom. Like no one is in your way. You are testing this thing according to your plan, according to how you wanted to test it. But that does not exist in unit testing, because I literally go, yep, I've written my codes, code written, I'm compiling the code, I'm executing the code, run. So I'm the one doing the coding, I'm the one doing the compiling, I'm the one doing the running, the execution, the testing. I'm even the one doing the reporting as well. That doesn't really work that much well, okay? And then once I've done that, there's something called high-level design. Now, high-level design is not necessarily code. It's just that I have designed a small part of the system. Say, for example, we're trying to build a school website. So somebody is working on the front end, someone is working on the back end. So there's a bit functionality in there. So I'm doing some of it. I've done the front end bit. So the back end guys have done their bit. What do? We merge it. Okay, we bring both together and compile it. We put them together. So that's something we call integration in the small. Okay, integration in the small is high-level design. It doesn't necessarily have to involve coding. Okay, but you put your own component together with another component. By the way, unit testing also is called component testing, because you built a component out of the application, you built some part of it. We can't call it part testing, but that's the best way I can explain it to you. So you've built a little bit of it, so you've tested. it works. Okay. So if it works, um, the other guys in the team that are building some other functions, other parts of it, will bring it all together, you compile it, you merge it together. And then we do integration testing because you've done your own testing and it works. How many of you have had this before? Oh, it works on my own system. If you complain something doesn't work, someone will tell you from somewhere, oh, it works on my own system. It works on my own laptop. It works on my own PC. Hang on a minute, it doesn't work on mine. Something is wrong between mine and a lot of the developer says that it's like it's their default response to everything. Oh, it works on my PC. Of course it does, but it doesn't work on mine. Okay, so I need to fix it. So we do integration testing on that. Integration testing means we're literally saying, can these two functions exist together? Would they work together? Can the code, can the components work together without breaking each other? Okay, that's integration testing. You're bringing one system into another. So you're saying, do they work together? Can we use them together? Okay. And once we've done that, we've compiled all the components. We now have a system. So we test it as a whole. So now you are not just testing the front end anymore. You are not just testing the back end anymore. Now you are testing the system itself. We call this end-to-end testing. Basically means you walk yourself from the start to finish. For example, if I want to go into the hospital to see a doctor or to be admitted, to be seen, to go into surgery, and then discharged, then I have to go back into the hospital for checkup after my surgery and all of that. I've just said something to you, may not make sense to you, but let me break it down for you. So basically, I have to get referred to the doctor, which is one test case. I have to get admitted into the hospital. I might probably be transferred from one location to another in the hospital. That's another test case. Then I would be booked on the X-ray, given an appointment to do X-ray, and then I'll go into surgery, which is the transfer to theater, and they'll do the surgery. They'll record my stats and everything. Then they transfer me back into the main hospital world, and then they discharge me. And then they give me an appointment to come back later to see them afterwards. See, that's system end-to-end testing. We call it system testing because you are now testing the whole part of the system. I hope you guys are hearing me, and I hope you can still see this one. Okay, so that's system testing for you. Now, once you've done that, and this feeds into the question you asked me, Shell, that does the customer take part in any final checks in the testing and integration? Now, look at the last exercise in the V model here. It says acceptance testing. Now, acceptance testing here means we've done all of it. We've built it, we've tested, we are comfortable with it. Let's get the end user on it. The end user is what? The client, the customer, some of them. So we build the school portal for them. What do? We call the headmaster or we call the school principal. We'll get 5 of their teachers, we get 50 of their students and go, guys, we need you to test it. You, the teacher, do all you should do on it. The student, do what you need to do on it. Principal, do your bit. We'll call some parents in as well. Parents use this system as well, and they do. That's acceptance testing. We get the end user to come and sit down before he actually goes into service. Okay, so that's acceptance testing. I think that answers your question, Sean. So that's the V model for you. For every level of activity on the left, there's a corresponding test activity, which makes a lot of sense. Okay. Now let's switch to the waterfall model on the right. It's still the same set of activities, but can you guys see where testing and integration is? Now, what difference can you notice here? And what comes to your mind? Comments. Between these two, it's still the same set of activities, but here we are waiting for them to finish the building and development, and then we test it. What comes to your mind? What do you think is going to be the first problem? What would you think we would encounter first as a problem? Or what do you think might throw us off? Do you think this would work? Anybody? While I'm waiting for your input. So basically, we've done the analysis, we've done the requirement specification, we've done the requirement gathering, we've done everything, we've designed it, we've developed it, and then we are testing it. And after we've tested it, we deploy it. So basically, we have to do unit integration, system acceptance testing, all sort of testing at once. Can anyone tell me what you think might be a problem here? Quickly. We don't have much time. Quickly. So I'll tell you. The first thing that comes to mind is this. Correct. That's correct, Jalili. If something is missing, they might have to start all over again. That's correct. Um, it may work depending on if it has been carried out before. That's absolutely actually correct as well. It may work if they've done what they should have done before, if they've seen it before, but it might work, not work as well. Now think about this. If we spend all the effort to build it and we have a built product, and then we tested it, and then we found a problem with it, how cheap will it be to fix? If we the later you find the defect, the more expensive it is to correct, to fix. So if the problem with it is at the code level and you've done everything before you start testing it, you have to break it down back, you have to backtrack to code level in order to fix it. Now that will cost you a fortune. Okay. Secondly, you may not even be able to backtrack. You might have to scrap that version and start again. That doesn't make sense. Not at all. Okay. This is why a lot of people don't use this methodology anymore. They don't use this model anymore. A lot of people have jettisoned this because, exactly, sure, it will consume time to test because now the testing we are doing is elaborate. It has to be robust. I mean, we have to check the codes, we have to check the integration, we have to check the system end-to-end testing. We have to do everything all at once, right? That may not be feasible. That may not actually work because we might find something fundamental that is wrong from the code level. Exactly, Faisal. If we have a problem, we've just wasted our time because we might have to take the whole thing apart and start again. Okay. Now you guys seem clearly, quickly, the disadvantage of this. Don't get me wrong, there's a disadvantage of the V model as well. And in the V model, not all of these things actually happen in every project. Some products are off the shelf. You buy them as a product. You don't develop them from scratch. So you buy them as a product and then you modify them, something we call configuration. So you don't necessarily do all of this. Okay. Meanwhile, sometimes you have to, if you are doing a development project, your developers have to test the code, you have to integrate it with something else, you have to integrate it with a payment system. For example, when you use an app these days and you have to make payment, and it takes you to PayPal or Paystack or Flutterwave or Stripe or whatever BBC, whatever payment platform it is these days. Those are different systems. Someone has to have tested that it worked together. It hasn't broken each other, that the integration between system A and B is correct. They understood each other. As a matter of fact, that's the easiest example I can give you. Think about Remitter with your bank account. Think about Paystack with your purchases. Think about trying to buy something on the internet using your card. You know, your bank system and the internet website provider, they are two different systems. Someone must have tested the integration between them to make sure they understand each other. Okay, now if you're doing that on the waterfall model, you must seriously have a deep pocket, because if you find a problem, if you find a priority one issue, we'll come to the priorities later in the classes, but if you find a serious problem, you might have to take the product apart. That's a disadvantage of waterfall. Disadvantage of V model means you need a lot of people. You need a lot. You need loads and loads of people. You need people who understand integration testing, because sometimes you have different testers. Sometimes some testers, they specialize in different fields. Some people will tell you, I'm a data migration tester. Even though I don't agree with it, some people only do data migration projects because that's their specialty. That's what they're skilled in. Some people only do end-to-end testing. Some people only do regression testing. Some people only do acceptance testing. Some people only do system testing. Some people only do some form of testing and not the other one. But when you're doing view model, you have to get these people in, all of them. So you might need, it will cost you more, or it will cost you more initially. And sometimes before you start seeing anything, before you start seeing any output, you'll be thinking, I'm just burning money, because you may not necessarily see anything. Now, these two are fundamentally the two-way streams of the models in the market, and you need to understand how these two works and why people use them and why people don't use them. Every other model falls between this law. This is extreme right, this is extreme left. Every other model fall between them. Agile is a component of this, which means we have a sprint. Our sprint is 3 weeks. In 3 weeks, we develop, test, fix, test, deploy. Basically, we're saying in 3 weeks, we want to develop this component. So we write the code, test it, integrate it, test it, put it together, test it, and then we merge it with something else. So a sprint, we fix all the defects, we retest it and all of that. A sprint is like 3 weeks. We can say a month or 2 weeks, whatever time is convenient for us. So once you understand these two concepts, spend some time playing with these two concepts, and try to understand how it works. Try to understand where you fit in these two models as a tester. Okay. Now moving on, still in the same chapter. Now, if you look at the context, okay, for every project in every industry, right, you need to understand the context of what you're doing. Okay, and your model should be adapted to what you're trying to do. Yeah, I'll give you an example. If you're testing an IoT device, for example, Internet of Things device that's connected to the internet, how many of you has access to Alexa? How many of you use Siri on your devices? How many of you use Cortana in your laptops? So we have some speakers now that use Alexa. So that's an IoT device. Okay. Now, IoT has so many different components. Each of these devices is further broken down into so many different components because the device as a whole is connected to the internet, which means there is a system within the device that's connected to the internet, which means there is a chip within the system within the device that is speaking to some other chip somewhere else over the internet. So you need to modelize. You need to moderate your whichever model you go for. You need to moderate it to fit the context of what you're trying to do. Now, if you are not integrating anything, you don't need to do integration testing. If you are testing something as a standalone product, let me take up something that is a standalone product. For example, say I am trying to I can't think of, because these days there's hardly a standalone product. But let's say you are building something that stands on its own, that's not connected to anything else. You don't need to do integration testing. Okay. If you're doing something and there's no technical use of it, only end users, there's no point doing technical testing on it. Get the end users in as soon as you can. Let them start playing with it. Okay. So you need to evolve whichever model you choose around this model. Okay, start from design to implementation to testing to evolution to requirement analysis. So it goes round and round. So you can take out something and chop a variation of it into it, depending on what you're doing. Okay, and depending on the project and what you're trying to do and the objectives, you may have to do some of this more than once. You may have to, because we have some testing models called test-driven development. So basically, your development is based on what testing you're doing, which is based on the result of the testing you're doing. Also, you want to do something in a behavioral driven development that is entirely dependent on the behavior of the application you're doing. So you need to always remember that. But the good thing is, as a tester, you are not in control of this. You don't choose this. Somebody like myself, maybe a test manager or the project manager or the program manager, would choose this for you. But you need to understand where you fit in, where testing happens, what sort of testing happens where in any model that your project is adopting. Okay. If you have any questions, please tell me. So that is that about software test lifecycle. Now let's talk about test levels. You know, I was saying, oh, we have components, integration system. What do this actually mean? Okay, so test levels for each level of testing, these are a core of test activities that are organized and managed together. Okay, you do these things in coordination to achieve the same purpose, the same objective at the same level. Okay, now each test level is an instance, is an iteration of the test process, the test approach you are adapting for your project. And in each level, these activities are bundled together, right? And you don't forget the context. They are relative to the given context, the level of development, the type of development you're doing, and all of that. You need to remember that, okay? So we're going to talk about these four test levels, and then we'll talk about some other ones. Because if you look here, I've written here, what about regression testing? What about exploratory testing? You might have had those before, so we'll come back to it in a bit. Okay? But let's talk about these core test levels, okay? And for each of these levels, there are characteristics to them. Yeah, each of them have the same attributes, but the definition of the attributes, the objective of the attributes differs. Like each of them have objectives, each of them have test bases to derive test cases. Yeah, each of them must have test objects. What is being tested? What's the purpose? What are we trying to do? You know, each of them will come up with their own defects and failures and faults. Don't forget that we talked about defect, errors, fault last week. And each of them will have their own specific approach and responsibilities for everyone. Okay? And each of them will happen in a certain environment. Now, all of these don't necessarily need to happen in the same environment. For those of you who don't know what environment means, environment is the domain, is the actual place where the product is developed and tested. You know, and as a tester, you must get used to the idea of a test environment, because test environment is where you do all your testing. Okay. Now, so the component one, I've talked about it to you, is a code test, usually done by the developer. Is also known as unit testing or module testing. So when you build a module or when you develop a module of something and you test it yourself. Okay. Now, objective. What are the objective here? You're trying to reduce risk. You're trying to find defects quickly. You're trying to compile your code to see if it works. There's no GUI, there's no buttons to click. It's just codes. Okay, it's just code. So if you find defect at that level, you are reducing risk. And you're trying to verify whether the functional or the non-functional behavior of the component is as designer specified. Okay, and you are building confidence in yourself that you've interpreted the product correctly. You are at the same time you're looking for defect to see if there is any defect that may give you problem further down, in the development cycle. Those are objective of component testing. Okay. Now, if you are doing incremental or iterative development model, like for example, Agile, where you do some module in a sprint and then do another sprint and then do another sprint, and then you can automate your component regression test. When we comes to the point where we start talking about automation and tools, this is a different level of class on its own, and we'll get to that. But I don't want to give you something that will be too much for you at the moment, because I want you to learn the fundamentals. I need you to understand how all of this fit together before you get to the more complicated stuff. Okay, so when you are doing sprints and you're doing modular building in sprint, you get to the point where you can automate your testing of the code. And there are so many tools we use for that. Jenkins, Splunk. Splunk will analyze the result report for you. Jenkins, continuous integration, we'll call it. GitHub, some people use GitHub, where you pull, merge, push, all sorts of that. We'll come to that. At the moment, I just need you to understand the concept of component testing, why we do it, what we're trying to do. Now, the basis of this is to have a detailed design. You write your code, you understand your data model and the specification of the component you're building. Okay, so those are the test bases. Those are the things you actually do. Okay, now the test object for this includes the unit or the module you're building. What exactly is it doing? If you are developing the admission functionality, for example, that's what you're focusing on: admission. Admit the patient, how do I put the patient in, where the patient goes or not. Code and data structure. How does the data look like relative to other data? What does the data table look like? What does the database look like? Those are the things that the unit testing think about. Those are the objects in the unit testing. Typical defect here includes data flow problems. It's not flowing correctly. Incorrect code. The logic is wrong. Incorrect functionality. You've misunderstood. You've introduced an error. These are the possible kind of defect you'll find in component testing. Okay, and the approach here is just basically someone write the code, whoever wrote the code, test the code. It's straightforward. It does come with planning. For example, if you are doing test-driven development, as soon as you write the code, you have to test it. And once you tested it, the result of the test drives further development, like I said. Okay, but you will get more information about this in the notes. But that's component testing for you. Now let's talk about integration testing here. Now, integration testing is a different kettle of fish. You've done the module, someone else has done the module, about 8 of us have done the module, now want to bring them together. So basically, I've done the handle, you've done the knee, someone else done the head gear, and we've done so we now want to bring everything together. So basically, we're saying all of our modules must work together. All of our modules are ready. We can integrate them now. So that's integration testing. Now, this is done by testers, not developers. This is done by testers. It's governed by a lot of different guidelines. For example, each of the modules must speak the same language. If you write your own module in Python, for example, and I wrote mine in Java, and that guy used C#, and that guy used SQL, and that guy used whatever, how do we let them speak to one another? We must be able to compile. These days, they use React Native, they use nodes, they use all sorts of compilers and languages that can quickly interpret what the other language is saying. Back in the days, we don't. And yes, I used to be a developer years ago, but I stopped because I can't sleep. Every time I close my eyes, I hallucinate. I can't see all I see is code. Okay, but integration, that's what we do. Now, some of the objective of the testing or overlap between different levels. Like all of them try to reduce risk. All of them try to build confidence. All of them try to verify whether the function or non-function requirement has been met. All of them are trying to find defect as well. So I won't be repeating that, but they are all part of it. Okay. Now integration testing focus on the interaction of the different modules, not entirely on the module itself. We've taken for given that the module works, is functional. But what integration testing wants to find out is, can this interact with the other modules without breaking anything else? And that is the core objective of integration testing. Now think about it this way. It could be web applications as well. It could be web services. It could be you're testing something like I mentioned to you, payment system from one platform to another. You're using an application that takes you into another application that takes you into another application and stuff like that. So we are looking at the relationship of these things from one to another, so that we can tell that it's actually they are working together, not as individual um, applications. Okay. Now, the kind of defect you find here, before I go into defect, the sort of objects you find in integration testing in modern days are like APIs, for example, yeah, interfaces, databases, subsystems, microservices. Now, these are like systems within systems, application within application, you know. So you can try them all out. You can get an API to a banking account system, for example, that you can use to test that if someone put their account number in on your website, you can validate the account number as genuine, as real, without actually connecting to the bank system. And that's done with the API. All of these things, all of these names, API, microservices, interfaces, structure, integration engine, should not be strange to you as a tester. You should know these things by now. You should start getting into the knowledge of these things, because these are things you come across every single day as a tester. Okay, and I'm trying to give you all of this information without scaring you. Even though it looks easy, it is not. It's a full-time job as well. Okay. Now, the sort of defect you will find in integration testing basically is mismatch, interface mismatch. This guy is speaking French, that guy is speaking Spanish, the other guy is speaking English. They don't understand each other. They are not communicating. As soon as you pull the plug together and you plug them in, it breaks that because that guy doesn't understand this guy. Mismatch, incorrect data, missing data, incorrect sequence of activities, failure in communication, you know, compiler, failure in compiling and stuff, incorrect messaging. Those are the kind of problems you find in integration testing. Okay. Don't forget, you can put your questions there anytime. I will try to answer them as I go along. Now, system testing, like I said, is the end-to-end. Everything must go. Sale. Everything is on sale. I want to see everything from start to finish. Now, this is where the bulk of the physical testing comes up. This is where people will see that you are actually doing something. Because here, you are not just looking at the integration, you are not just looking at the module, you are looking at everything. I'm talking about everything. For example, if you want to do something that will go from software to hardware to printing to scanning to faxing, all of that is included in system testing. So I want to go to a hospital for an hospital appointment, and they need to send me a letter to my house. They need to generate the correspondence. They need to print it. They need to send it to my house address. I should get the letter. I should take the letter with me. They need to have access to my medication. They need to know that because they have to have access to the medication system. They need to have access to the pharmaceutical system. They need to have access to my personal medical record. They need to know what my allergies are. They need to know what my medications are. They need to know all sorts of things so they go across all sorts of systems. So when you develop your test scenarios in end-to-end testing, it covers everything. Yes, it does. It generally it does. It checks. Beware of using the word check. Checking is a form of testing. Is an informal, irregular form of testing. You usually don't document checking, and you don't want to do a checklist. So beware of using the word checking. I would rather you say testing. Now, if you're checking interoperability, you might just say, "Oh, when I put this on, is that off?" No, it doesn't. I can make that assumption that it works together without actually doing anything else. But for me to give you an assurance that it does work together, I should do some tests. I should input data from one and check the output from the other. So I would beware of using the term checking generally, but yes, it does, to answer your question. Now, all of the objective I've mentioned before applies to system testing as well, but more, because now you are not just looking at is a part of it, you're looking at everything. You are looking at the whole system now. So you want to find the defects. Any defect that is left, you want to find them here. This is where you want to find them. Okay? This is where you want to find them. This is where you want to find out why they don't work together, what sort of things you could do, how you can improve. This is where you test everything. This is where you define the how-tos, workflows, work processes. This is where you define them because you are doing end to end. You're starting from A and you're going to Z. Okay? So this is where everything happens. This is where you test everything. And nothing is off the table. Yes, they are the same thing, Jalili. You can either call them component testing or unit testing or modular testing. All three of them are the same. You'll find more explanation in the notes that come with the recording when I send them out to you. So system testing encompasses everything that you want to do. Basically, it applies to everything. It applies to applications, to hardware, software system, operating systems, systems under test, infrastructure, test, in all sorts of things. Once you get to the system testing, that is the bulk of the testing. That is where you spend more time doing testing. That is where you will probe the system more. And that is where you get a better understanding of how the system works. So you are testing the entire system. You're testing everything. Okay? And defects here, knock yourself out. All sorts of defects. All sorts of defects. You find all sorts from things you could have found in unit testing, integration, all sorts of testing. Here, you could have incorrect formula, incorrect calculation, incorrect control or data flow problem, misrepresentation of data, misrepresentation of workflow, all sorts of issues. There's nothing left out. If your system testing is robust, you would find all sorts of issues, defects at this point. Okay? Now, fundamentally, I would say those 4 test levels are what you need to understand. But that is not 100% of it. Now, I don't know if you've heard about the term regression testing, exploratory testing before. Now, where does this fit into this? Now, hold that thought because I'll come back here. Okay? Let's move on. Right? Now, chapter 3, we've just done test levels. Okay? Before we move on to that, I think I missed one. Yeah, acceptance testing. Sorry, I missed up acceptance testing. Right. So acceptance testing is basically, it's not the same as system testing. Now, it's done by testers and non-testers. Now, system testing is done by testers. That is what we do. In fact, that is our domain. That is where we earn our money. That is where we learn our trade. That is where we display our skill. Now, acceptance testing, we could either have user acceptance testing or you could have operational acceptance testing. What's the difference? Now, the end user, we went there and we told them the system is ready, we're good to go. But to build confidence, to test usability, to measure the usability. We want you guys to try it out. Tell us what you think. It's not live yet. You're just giving them the opportunity to play with it. You could put that in the play environment. They could use it in the test environment. They could use it in any environment apart from live environment, which is production. And they play with it. It builds confidence for them. It validates the system for them that you've interpreted their requirement correctly and accurately. Okay. So operationally, they can sign it off that yes, we can use this. I don't want to follow my chair, but I'm feeling like I'm going to follow my chair. Right. Operationally, they could sign it off and says yes, it's operational. We can use it. It doesn't come with any added risk. Uh, whatever risk is there, we can mitigate it. We are happy with it. Oh, it builds confidence of the users that are quite like this. It's slick. How many of you have had that term used when people are describing applications? Oh, have you used that app? It's slick. Oh, it's smooth. It's this and that and all of that. Basically, all of those things are done as acceptance testing, and that's what the end user do. And usually, we find cosmetic issues in acceptance testing. I would rather not get to this point to start seeing serious defects. I want to have found all my serious defects before we get to UAT or OAT. The reason being, it takes just one person, one customer to say it's rubbish, and you will barely recover from that. If I want to do something and I come to your school, for example, and there are 50 of you in the class, and I've labeled to make sure you guys like it, and I open up to you, and one of you found a problem, and we struggled to fix the problem, we couldn't make it work for you, and you said, this system doesn't work, it's rubbish. How many people in your class do you think would believe the system is not rubbish? Zero. I've had people say to me, oh, the system is rubbish, it's unusable. And when you look at the logs, they've not even switched it on. They've not even logged in. Their login has still, it's not even been activated. But they will sit in front of you and tell you the system is rubbish. How did they know? How did they find out that exactly Moses? How did they even know that it's rubbish? They've not even tried it. They've not even used it because we created the login profiles for them. We can see which profile has been used. They've not even tried to log into the application, but they will tell you it's rubbish. How? Why? Because someone has mentioned in their hearing that the system is rubbish, which is why, as testers, we want to find all the defects before we get to that point. And I always say this, I don't like surprises. A few people who knows me will know I say that a lot. I don't like surprises. I want to know. I don't want breaking news. If anything is wrong with the system, I want to know. So I can tell the end user, this bit is not working yet. We are trying to fix it, which is absolutely acceptable. I'm managing your expectation. I'm not raising your hopes falsely. I'm not giving you false expectation. No, no, no. Admission functionality is not working, but we're trying to fix it. But the other works. So don't test the admission, test everything else. Ideally, I don't want to be saying that to the end user, but if I am in that situation, I'm going to have to say it anyway. Okay? But usually, ideally, if your system testing is robust enough, you want to catch all the defects, all the serious, let's put it that way, because you can't find all the defects anyway. But you want to find all the serious defects before your end user sits on it. By the time your end user sits on it, you don't want them finding functional issues like, oh, this doesn't work, oh, that doesn't work. Now, if someone says, oh, they spelled my name wrongly, fine, fair enough. I can live with that because I may not know your name. I'm British. Adebayo is not a British name. Most of my colleagues can't even pronounce my name. So if they spell my name wrongly, I can live with it. Okay? So those are the kind of things you find in acceptance testing. Those are the kind of things you should find. And then the kind of issues that come up in operational acceptance testing is things like backup and restore and rollback. Say if we are going live with this thing and it doesn't work, how do we roll back to what we had before? Disaster recovery, user management profiles. And I think you guys should go and Google RBAC, RBAC, find out what it means. It's role-based access control. Basically, if you are a nurse and you are logging into a clinical system, you should not be able to do what a doctor would do. Some of you understand this. If you're a doctor, you should only be able to do what a doctor can do. If you're a supervisor, you should only be able to do what a supervisor can do. In the banking system, a clerk should not be able to approve an overdraft. A bank clerk should not be able to approve a loan. Those are done by underwriters, risk underwriters, and all of that. So those are different levels, roles, controls. So those are the things that come up in acceptance testing. I'm a manager. What sort of access do I have? Can I add more people? Can I, if I have leavers and joiners, can I take them out? Can I add them in? All sorts of things like that. Those are the kind of issues you find in operational acceptance testing. And then you have uh, uh, contractual acceptance testing because it's stated in the contract that you have to test it. You need to provide a report that you've tested it. This is how it is. Or regulatory, that as part of the regulation guiding the project you're building, which we discussed last week as well, you have to show that you've tested it and the testing has passed. He has passed some kind of checks. So all of them. Then some people say, oh, our acceptance testing is alpha, beta testing, and all that. Now, alpha and beta testing are usually used by developers of the shelf product. We call them COTS. The product has been built before that we've bought and we've configured. We can alpha or beta test it. So we give a lot of people access to a dummy production environment to test it, sometimes in the production environment as well. So that's not any difference to acceptance testing. It's just different type of acceptance testing. Okay. Um, Bear in mind that we've not talked about regression and exploratory, but we'll get there in a bit. So we've talked about test levels. Okay. Now I want to talk to you about test types. These are different from test levels. Okay. Now test types. Now when you have an application, you have different kind of types of tests. Now test levels. More than one test level can fall into more than one of these groups, as you can see from the chart here. But let's take it one at a time. So you have static testing. Static testing means someone gave you a spreadsheet of requirement and you are going through the requirement saying, oh, this is testable. That is not. You're testing. It's static. If I say you should be, the end user should be able to log in, that's a testable requirement. Yeah, we can test that when it's ready. If I say the end user must wear appropriate clothing, how do you test that? What is appropriate clothing? Should you wear high vis, reflective jacket, um, fireproof jacket? What exactly do I mean? So all of these are different type of testing. Functional. Functional means is a function related. There's a button to click, there is something to do, it does something. There's a GUI there, there's API there, there's core of the system, there's a function attached to it, there's a discharge function, there's a payments function, there's a transfer function, there's all sorts of different functions in all sorts of systems. That's functional, anything that you have to physically do something. And then you have non-functional, something some other people call performance, but I prefer to call it non-functional because performance is just one aspect of non-functional. So this here should be non-functional. But when you go out there and you hear someone saying, oh, I need someone to do performance testing, they are asking you to do all of this. They are basically asking you to come and do non-functional. It's an acceptable language, but it's wrong. How we came about accepting it, I don't know. Because performance testing is a type of non-functional. So basically, when you launch a website, you see how long it takes to load, you see if it displays properly, you see if the fonts are out of place, you see if the fields are out of place. That's performance. You're assessing the performance of it. Then load. If a system is built to be used by 1 billion people and you have 6 million people on it, it's going to break. How many of you have had someone broke the internet or someone broke the website? Kim Kardashian would do something and everyone would rush to the website and the website would break because it can't undo that traffic. I'll give you an example. There was one of my websites that I had. I think it's about 2 years ago, and we had a guest did a video with us, and the video was published. And before that video was published, we were averaging about 10,000, 11,000 unit traffic a day. And all of a sudden, like 2 hours, we're averaging like 600,000. And I have the guy, the infrastructure guy ringing me like, Ade, what's going on? You're at breakpoint. You're at breakpoint. I'm like, no, I shouldn't be at breakpoint. Scale it up, So load, stress, volume, capacity testing, performance testing, they are all non-functional. Question, where does a manual click test? Where does a manual click test? Is it functional or performance? Manual click is functional. If you're clicking on something, it's functional. Okay? If you're clicking to see what the button does, if you're clicking a button, that's a function. If you click a button, you are trying to exercise the function. What does the function do? What does the button do? Okay. Another question, and yes, is it functional? It could be a performance, but it's always usual function. Okay. Another question says, is there anything like the maximum load? Of course, definitely. If you build a system and you could only have 1,500 users on it, that is the maximum load you could take. So if all 1,500 people logged on, the system would barely cope with it. If you had another one user to it, the system will break. It will collapse because it's only built for 1,500 users. Jalili, come on. You're talking about the recruitment portals. Nigeria has a population of 200 million people. I don't think there's any system in Nigeria, apart from the BVN, that was built to cater for that much people. There might be, but from what we are seeing, and to buttress your point, a lot of them breaks all the time. Most of them don't work. And when I run checks, when I test most of their website out of boredom, I just laugh because most of them don't work at all. So let's not even go there. Security testing, we have penetration testing, we have security testing, we have white box authentication. A lot of you will have seen some websites will put captcha on it. Some will say validate your email and all of that. Now, let me teach you something. So I'm going to ask you a question now. If you know the answer, pop the answer there. If you take a car to the mechanic, to the garage, to service your car, and the mechanic takes apart your car, take out your plugs, filter, take out everything there, take them out, spark plug, filter, and what sort of testing is the mechanic doing? And if you do a search in Google, this is the second part. If you do a search in Google, say, I want to search for Jelili Odunayo, what sort of testing is that? Can someone tell me? What's the difference between these two testings? What's the difference between them? Someone says, my website I built that crashed. Could I have rebuilt it to increase maximum? No. Yeah, it didn't crash. It almost crashed. The reason it's almost crashed is as a result of so many things. One, the bandwidth was tiny, so they increased the bandwidth. Two, the maximum load we specified in the database was breached. So we didn't have to rebuild it. We just need to scale it up. Okay, that's an answer to your question, Pfizer. We don't have to rebuild the website. We scale it up. There is a lot of architecture that surrounds website, so you don't necessarily have to rebuild the website. You can just increase the website space. You can increase the RAM space. You can increase a lot of different. You can scale it up in a lot of different ways. Right. So to my question, Jalili said the mechanic is doing unit testing. Okay. I kind of agree with you a little bit. Okay. Now, the point I'm getting to is the mechanic has taken the system apart to the individual units. Okay. So the mechanic is looking at everything going on inside of all of those units. That's transparent. He's seeing everything. That's white box testing. White box testing means you are seeing everything that is inside of it, how you know the inner workings of it, you know how it works inside of it. So that's white box. If you go on Google and you type in, you want to search for Francis, and you just type in Francis and you press enter, can you see the algorithm that Google runs that give you the result? No, you can't. Well, it does work, right? You just run your query and give you a result. You don't know how that happened. You don't see the algorithm. You don't see the formula. You don't see anything. You just put the input in, you get your output. You don't, most of us don't even care how it happens. We don't care how you find Jalili in Google. I don't care. Just find Jalili. It might come back and not find the exact Jalili I'm looking for, but the bottom line is it's gone ahead and find me a Jalili somewhere. It's gone ahead and find me Francis somewhere. How did you do it? I don't care. I don't want to know. That's black box testing. Do you guys understand the difference between the two now? So don't get peeved if someone around you says, "Oh, do you understand black box testing? Do you understand white box testing?" And these things do come up a lot in interviews, and you need to know these things. You need to know the difference between them. So if someone is testing something, but is testing the inner workings of it, like a mechanic, like a unit tester, they are doing white box testing. Now, white box testing may not be functional. It may even be security related. There's something called penetration testing. Yeah, it may be non-functional. A lot of different testing things like that. You need to understand what these terms means because you will be asked a lot. As a matter of fact, a lot of employers look for people who understand these things, not necessarily who can do them. They look for people who understand them. So they ask you, "Oh, do you understand the concept of white box testing?" If you say yes, you get a job. Do you understand black box testing? If you say yes, you get a job. So these things you need to know. And that brings me back here. Regression testing and exploratory testing. When you, okay, don't worry. We'll come back to that. Let's move on. So basically, if you want to look at the comparison between functional and non-functional, look at these two diagrams. Now, if we go back to this diagram here, can anyone tell me what should be in the place of coding here? Can anyone make a guess? What should be here? Can anyone make a guess? What should be here? Can you guys hear me? Are you still there? Can anyone guess what could be in place of coding? How about we call it project or product? Because whatever we are doing is starting from the top here. This is the actual project. Okay, that's that. Now, when we were talking here, I didn't say anything about regression or exploratory. Now, I also say here that instead of putting performance here, it should be non-functional. Now, exactly right. It should be. Because if you look at the image on the right here, it says non-functional testing. Now, all of those test types around it are non-functional. These are things you can see either by looking at it, by measuring it. Oh, sorry, I didn't know. Sorry, I'm so sorry about that. Right. So the non-functioning test, you can see there. The functional, you can see there. Now, if you look at the image of the functional, there are systems within systems within systems. Okay, I don't want to spend too much time, but I've given you these two images so you have an idea of how these things relate to one another. Now, this last chapter will take us into the remit of regression and exploratory testing. Okay, so what is maintenance testing? When do we do it? Now, so we build our product, it's gone, we've done all our testing, we've written our test report, everything is fine, we are all happy with it. So it's gone live. But what usually happens after a project has gone live? We do upgrade, right? We do, oh, we find a lot of defects, we patch them up, we apply the fixes to it, right? We have a new version of function, we have a new interface, we have a new GUI, we improve on the system. We improve the feel, the look and feel of the application. Okay? If you Google Facebook, if you look at Facebook now, compare the Facebook screen of 2007 to what you have now, it's different. If you compare BBC News website now to what you have in 2007, it's different. So they improve over time. With each improvement comes some testing. And this is where regression testing comes in. Now, don't confuse regression testing with retesting. Regression testing means it's gone live, we are upgrading stuff, so we need to continually test that while we are changing stuff, we have not broken anything else. So the function that worked yesterday, they continue to work even while we are changing stuff. The faces, the pages that were loading well yesterday, they must continue to load even though we are making changes to the system. We are not breaking anything. That's maintenance. Now, maintenance is done to guarantee compatibility, reliability, performance, efficiency, portability of the product. Now, once you modify something, once you move the product from one environment to another, from one platform to another, a lot of projects that is happening now, a lot of applications are being converted from desktop application to cloud-based application. A lot of you know about Amazon AWS, Microsoft Azure, Google Cloud platform. A lot of products are now moving from desktop to cloud-based. A lot of web applications are becoming cloud-based. We are using less physical infrastructures now. So a lot of these things are going into cloud-based infrastructure framework. So now you see a lot of modification happening. You see a lot of regression tests happening. You see a lot of regression packs being defined, regression tests being done. You see a lot of regression tests. Regression is the prime candidate for automation, because you want to automate the things you do repeatedly that don't change. Okay, so you want to do the same thing, the same thing, the same thing over and again. You can automate those things. That leads into automation. So the triggers for maintenance testing is modification, migration, retirement or deactivation of a component of the system. Say we are no longer using this component, we are using another one. We need to test it again to make sure the new one works with the rest of the system, taking out the old one, taking out that the old one, taking out the old one doesn't break the system. I have a question here that why is it that when some mobile network upgrade their sites, the site may not be accessible for customers for a while? There are so many reasons. This could be due to so many reasons. I have done testing in live before. I have taken system down before. So what I know is what I'm going to tell you. When we are going live, either with an upgrade or a new system, we take the system down for a particular time. Now, we could take it down for a whole weekend. We could take it down for 4 hours. We could take it down for 8 hours. During that time, you would not be able to access the system. Now, if everything goes well as planned, after we've done what we are doing, and we say the system is back now, you should be able to access it. Now, Access Bank in Nigeria recently did something. I don't know if it's an upgrade or I don't know. And for a whole weekend, the banking platform was not available. Now, that tells me something has gone wrong. It doesn't necessarily have to be testing. It doesn't even necessarily have to be anything. It's just me. That project as a whole, something has gone wrong. So there could be a lot of reasons for that. They might genuinely take it down so you can't access it. They might run into a problem, so the project overrun. They might say, oh, we want to take it down, like, for example, Barclays. Barclays banks will tell you specifically, we are taking the system down between 11:59 on Sunday and 3:59 in the morning. They specifically tell you, 11:59 on Sunday, you won't be able to access the system. By 4 a.m. on Monday morning, you will get into the system. So is a is is a is a matter of what is happening, how the project has gone. So that could explain why customers may not be able to access the website. They might have taken the website down. Sometimes we forget to recycle servers or turn things back on. A lot of things could go wrong. I have lots of examples. I did a project once, and one of my testers forgot that we are live, and thinking she was still in the test environment, she deleted something. And we saw it straight away in the production environment because she was in live. So a lot of things could go wrong in the background that could extend the time the system is not available. Regression testing, a function of maintenance testing, it is not a function of maintenance testing. Regression testing is a type of testing that you do as a result of maintaining your system or application. So every time you modify, you have to test that everything that was working before continues to work. Okay? You have to make sure that nothing has been broken. So when you move your application, for example, if you are running on Windows and you want to move to Unix, for example, whatever it is you want to move, you want to check that all of your application works in Unix. For example, I don't know if many of you knows that when we are using Internet Explorer 8, a lot of applications were working on IE 8 that did not work on IE 16. A lot of application works well with Chrome. For example, this webinar tool that we're using, Click Meeting, they will tell you to get the best performance, use Chrome. Why? Why can't we use Edge? Why can't we use Safari? Why can't we use Firefox? So it depends. So when you do stuff, you need to check them to make sure that nothing else has been broken. All the things that are working are continuing to work. Is regression testing only carried out after the product or application goes live? Not necessarily. You can carry out regression testing during project life. If you're doing testing and you're doing, you've designed your testing in such a way that you're testing the whole functionality, your system testing is robust, end-to-end test case scenarios, and you are putting a fine comb to it, combing everything as you go. Now you are iterating the test, and most of the time you are repeating the same test. You could automate some of that as regression testing. especially if they've told you that nothing has changed in those functions, but we are adding new stuff. Like if you are building a module, like the last project I did, we didn't have the full product at once. We were getting them in modules. We were getting some were not ready, some were ready. So we've tested some from as early as March, and we didn't get some function as late as August. So we need to make sure that everything that we've tested in February, March, April, that we've signed off as working, they continue to work. Okay, so you can do regression testing before it goes live, depending on the methodology or the model you're using for your deployment. Another question says, what about in situation where the product is still under development, but the developer has to change the code or something? Can we carry out a regression test to make sure no link has been broken? Absolutely. If you tell your developer that the landing page works and is fine, and then the developer says, oh, I need to change the banner at the top of the landing page, or the landing page works, but when you go from the landing page to another page, the developer is making changes to that page, not the landing page. First of all, you need to continue to guarantee that your landing page works. Your landing page must continue to work, despite the fact that no change is being applied to the landing page. The change is being applied to another page, which you go through the landing page to. So, yes, you need to ensure that nothing that was working before has been broken. That's the whole point of regression testing. Okay? That is not the same thing as retesting. Retesting is you found a problem, the problem has been fixed. So you are retesting that incident that created the defect to make sure actually that thing has been fixed. And usually, after you've done the retesting, you go back and do regression testing. Do you understand? So this is what we've learned today is basically the things you need to remember a lot. These are the things you need to practice every day as a tester on the job. These are the things you will come across daily. So I would encourage you to listen to this recording, to read the accompanying notes to this session as many times as you can, because most of the stuff you had today, you're going to come across them every single day in your career as a tester. Okay, so I'm still going to continue taking your questions, but I want to tell you we've come to the end of the class now. Thanks for attending the class. I will announce the next class very soon. For those of you in Nigeria, I have a bonus for you. Uh, I'll give each of you, I don't know how you buy your data, I don't know how much data you use for this class, but I'll give each of you 1,000 naira towards data for your next class. You need to contact the admin of our meetup group to put your name down so we know how to get your data to you. That's just me. That's just me helping you to access this because we are all home. So I need you to be able to come to class because this is now a class. We are in a school. So thank you very much for attending. It's been great having you here. The resources were available. Before you go, I want to show you something before you go. So this is great. And I want to, I don't know, I want to show you, but at the same time, I want to keep it under wrap, but I don't want to keep it under wrap. So this is what I'm going to do. I'll mention this to you and I'll implore you to go and have a look. So I want to share my screen with you. So let me go to share my screen. This one. Right, guys, can you see the screen here? Can everyone see the screen? If you can see the screen, can you tell me yes here? Okay, now, where is it? This is not the screen. No. Can you see this screen? So this screen here, this is our website for our crowd testing. As you can see, this is currently being done. So on here, you would have resources. You would have resources for each class will be there. You would have event details here. You have the resources. You have the blogs here as well. You have pictures from our physical activities and all of that. But for you to be able to use this site, you have to register. And your registration will be validated because we are going to be paying you when we do live project. So for all the testing on live project I would do, it's going to come with payment. So when you find issues, for example, it might be the budget is 5,000 naira per issue you find on project A. Oh, don't worry, the registration link will be sent to you when it's ready. It's not ready yet. I'm building it gradually. So, but I expect it to be ready in the next couple of weeks. So please bear with me. But this is going to be our home. Our Twitter handle is going to be at Niger Test, at Niger Crowd Test. I will put all of this information out there so you can see. So all of you will have access to it. You're going to register. So all of us will be part of this platform and we're going to use it. We don't have a WhatsApp group. I don't want us to put a WhatsApp group together yet. But if you guys want one, I can create one. But I don't want us to do that yet. I want us to be active. And please, don't forget to send your email address to the admin of our meetup group, or you can send it to me and forward it to her. Our meetup group, you need to be active. I don't want us to just be there. It's not for show. It's a learning platform. I want to teach you stuff. You want to learn stuff. Ask me what you want to know. So I know how to give you the service. So I know what to provide in service to you. I don't want to be doing the thinking by myself. So if you help me with, Ade, how does this work? For example, when we get to the point where we're using tools, when we get to the classes where I have to teach you Jira, I have to teach you how to use ALM, different sort of Selenium WebDriver, all of those things. Those classes will not be free. The reason they will not be free is because those tools will cost me money to get for you guys to have access to it. So you are not paying me to teach you. I'll teach you for free. But you need to pay to have access to those things for like 3 months. So you can play with it on your own. You can play with them and then you can play and then ask questions later on. Does that make sense? So I'm trying to make this as interactive as possible so you know how it works. And then once we've learned it, we'll go on our portal. I already have a lineup for project that will come. It's going to blow your mind, guys. Trust me. We have mobile application in development that's going to go into testing soon. We have more than one of that at the moment. We have a web application as well. We have another web application upcoming. The website itself, I would open it to you guys to test. It's your platform. So we're going to test it ourselves. We're going to use it to practice. And then we'll go ahead and start saying to everyone who is building applications in Nigeria from wherever in the world that we are a group of professional testers and we can test the application. So we do crowd testing. They give us the application, we test it for them. We write our report and send it off. Then we take on the next job. So this will be like what you guys call side hustle in Nigeria, but it's really not, basically. But